So in this example, we have a guy riding a Ferris wheel, and we're going to determine the normal force at the top and the bottom of the Ferris wheel. The radius of the Ferris wheel is 87 meters. We know that it goes around once every 25 seconds. And remember, with the radius and the time, we can determine the velocity. And the man has a mass of 55 kilograms. So considering the point where he's at the top of the Ferris wheel, the normal force points upwards, the weight points downwards, and that's equal to the radial acceleration, which in this case will be negative because it's pointing downwards. And we find that the normal force and so we can find the normal force by just finding the weight minus the radial acceleration, or minus the centripetal force. In order to do that, we need to find the velocity, and the velocity comes from the radius of the Ferris wheel and the period, the time it takes for one revolution. And so if we just plug in what we know about the velocity in terms of the radius and the period, and then plug in the values that we know, we find that the weight of 539 newtons minus the centripetal force of 302 newtons and the normal force at the top of the Ferris wheel, 236.75 newtons. Now we can solve the same problem for the bottom of the Ferris wheel, except this time the directions are different. The normal force still points in the positive direction, the weight still points in the negative direction. But now the centripetal force and the radial acceleration point upwards towards the center of the circle. So it is also positive. And so here the normal force is just going to be the sum of the weight and the centripetal force. If we add them together, we find that the normal force at the bottom of the Ferris wheel is 841.25 newtons.